This video, we're going to talk about velocity and acceleration, and I've got the calculator ready just so it can help me when I need to plug in some numbers and get some values here so I don't have to do all that by hand for these application problems. Our first problem that we're going to work is number 35, and it asks a ball is propelled straight upward from the ground level, so initial height S sub 0 is 0 feet. Initial velocity they're going to give us is 144 feet per second upward. And then we need to know the acceleration due to gravity. Since I'm in feet is my unit of measure here, is going to be negative 32 feet per second squared. That'll show up in the problem here in a little bit. So my position equation S of t is equal to 1/2 gt squared plus v0t plus s0. So for part A, initial position is 1/2 of negative 32 t squared plus 144 t plus 0. S of t is a negative 16 t squared plus 144 t. And then we want to find the height and velocity at t is equal to 3. So let's go ahead and finish this up with the velocity equation, which will be negative 32t plus 144, and the acceleration equation, which will be s double prime of t is equal to negative 32. Position is measured in feet, velocity is measured in feet per second, and acceleration is measured in feet per second squared. So for part B, they ask us to find all of those things: position, velocity, and acceleration when t is 3. So let's go ahead here and plug in negative 16x squared plus 144x, and let's plug in negative 32x plus 144. Let's let the calculator do a little bit of work for us, that it can find those values for us. So we have 288 feet is my height, and my S prime, which is my V, is going to be 48 feet per second. And we know our acceleration is constant, so that's why I didn't need to plug that into the calculator. That is a negative 32 feet per second squared. Okay. So this is when it is at its highest point. Kind of imagine it going up and coming back down like that. And we're talking about, it's not at its highest point yet. I'm sorry, this is 3 seconds in. So we are somewhere we're somewhere around here. Knowing the flight path of this, we're right there, t equals 3. We are at 288 feet off the ground. We're traveling upwards at 48 feet per second, and gravity is pulling us down at 32 feet per second squared. We're getting close to this top point though, which is what we want to find in part C. Is, okay, special thing going on here at this high point is that the velocity here is equal to 0 at this point. because I lost all of my upward speed before I start going downward. So there's no speed right there, no velocity. So I can take the velocity equation and set it equal to 0. And solve. So let's go ahead and look for the 0 of the velocity equation here, which let's zoom out just a little bit. Okay, so where does it cross the x-axis there? Second calc 0, and I want to be on my red equation. Left bound is, there we go. There's a left bound and there's a right bound. And so it says that the answer here is t equals 4.5. I can also, that's in seconds. I can also find that by saying negative 16t equals negative 144. And t is equal to 144 divided by 16. If I put that out here on my home screen, sorry, this is 32. What did I say? 16. This is minus 32, 32, 32 is 4.5. It's right there. I just wrote it down wrong. And so seconds. And now we want to put that in. So S at 4.5 seconds. Let's come into our table at 4.5 seconds. We have our height above the ground is 324 feet. And we know our velocity above the, at that point is 0. So 324 feet off the ground at part C, the highest point. Then we want part D. Let me go ahead and scroll here for part D, which is what happens when it strikes the ground, how fast is it going? So when we come back and hit the ground, let's look at our graph again. That's over here at this 0 of the blue graph over here. I'm going to also get this by factoring, but this is here, and then definitely over there somewhere. Come back. There is at t is 9. So we're interested in s of t equals negative 16t squared plus 144t, which is equal to a negative 16t times t minus 9. So t equals, if I set this equal to 0 to find out when it's at ground level, we know it's at ground level when t equals 0, the initial time in the problem, but also at t equals 9 seconds. So I want to find v of 9 seconds. So that's going to be negative 32 times 9 plus 144. I'm again just going to let the calculator do that for me. V is my red equation there. And so I have a negative 144 feet per second. Notice that that's the same as my initial velocity, but it's in the opposite direction. It's a down now, so that's why it's negative, because it's coming back down towards the ground instead of going up away from the ground. So that's kind of the answer to the question of how is the speed related to the initial velocity? It's equal but opposite, right? Okay, let's go ahead and look at number 37. And it says that the velocity v in feet per second of an automobile starting from rest is given by v is equal to 90t divided by t plus 10, and we'll call this v of t. I'm not going to do u's and v's for my chart over here because I'm using v over here on the left side. I'm just going to do the quotient rule from my head. Derivative of the numerator is going to be 90 times the denominator minus derivative of the denominator is 1 times the numerator all over the denominator squared. That's going to be 90t plus 900 minus 90t over t plus 10 quantity squared. So that's going to be 900 over t plus 10 quantity squared. Let's go ahead and put these equations in y1 and y2. So I have 90x divided by the quantity x plus 10. And then I have 900 divided by quantity x plus 10 squared. And they want us to make a chart, a table here of the different values at 10-second intervals. So 0, 10, 20, 30, 40, 50, and then 60. Okay. So I'm going to round any of my velocities here to the nearest tenth, and any of my accelerations I'm going to round to the nearest hundredth. So we have t, v, and a. And this is going to be at 0 seconds, 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds, and just know that v is in feet per second and a is in feet per second squared. So start off with 0 for v, then 45, then 60, then 67.5, then 72, then 75, and then round that to 77.1 for when t is 60. Okay, then for my a, this is starting off at 9, then it quickly decreases to 2.25, then 1, then we're going to call that 0.56, then exactly 0.36, then 0.25, and then 0.18 approximately. And again, these are feet per second squared for acceleration. So that's it for this topic, and that's it for 2.6. We'll come back next time and we'll talk about our topics from 2.7, which will start our discussion on implicit differentiation. What happens when we want to take a derivative and we can't separate all of the x's from the y's? How do we deal with that? And it's really related to the chain rule. So I'll come back and we'll talk about that next time. See you for the next video.